when we approach this question, sometimes it's always good to depict the scenario by drawing briefly what's happening. So let's say our object is thrown vertically upwards at 20 meters per second. What kind of velocity could we describe that one as? An initial velocity, very good, so we use u as initial velocity. Okay, so this object goes up to some maximum height, but then it's going to go down, back down to the ground. So when it gets to its maximum height, up top here, what can we conclude about its motion? Yes, it's achieved a point where it stops briefly, so its final velocity at the very top is going to be 0 meters per second. All right, because it's stationary at that point. Now, the goal is to determine a maximum height, so that could be thought as a displacement from the ground, from where it started, perhaps. What else do we know about the motion of this object? What will it experience? Yes, it's going to experience a deceleration. Yeah? It's going to slow down. By how much? Well, it's going to have an acceleration in the downwards direction. Okay, we're going to have a negative 9.8 meters per second squared, perhaps. So, what's an appropriate rule that could help us calculate the height or displacement if we know velocities and an acceleration? That's the one. Okay, so in this we let the final velocity equal to a 0. We know its initial velocity of 20 meters per second squared minus, now this is 2 times, this is where we add our negative 9.8, so that's the same as just doing a subtraction, multiplied by x. Okay, so in solving for this, we got to subtract this term to the other side, so that's a 400 over 2 times 9.8, which is about 19.6. Who did that same calculation on their examples? Yeah? Yes? Okay, and approximately, what kind of result did we achieve? 20.4? So, this lesson we're going to know and understand projectile motion. So the things I want you to be able to do is determine and understand vertical and horizontal parts of motion. Okay? Because projectile motion is in two-dimensional motion, we need to break it down into 2 one-dimensional parts. One part is just a horizontal travel. The other part is a vertical travel. When you put both together, it creates that parabola. Does that make sense? We want to be able to determine the maximum height and then the range, which the range is what we're going to interpret as the horizontal distance achieved. So, in this lesson today, what I'd like us to be able to do, please, from our Google site, I'd like you to be able to demonstrate your learning. So in this, at the bottom where it says check your understanding, I want you to demonstrate your learning by creating a meme today from of a piece of work that you've been able to complete yourself that meets the success criteria. Or what you could also do is come down to... No. Now, I'd like you to... You can also demonstrate your understanding by coming to this shared document on the Google site. So if we look at this shared document here, what I'd like you to do with this is, by the end of this session, as part of your reflection, I want you to capture one part of your work that either shows that you've determined a horizontal or vertical component of motion, that you've been able to work out the maximum height of a projectile or determine the range of a projectile, or determine the time taken for a projectile to reach its range, its max distance, and provide evidence in this column. Okay, so it might be for an image or a link to a piece of work that you've uploaded, and then explain what you've demonstrated here. You might say, oh, I've been able to determine the range in this example. All right, I want you to be able to justify it, because it's all very good in being able to answer a question, but what have you demonstrated? What have you learned from today's lesson? I want you to be able to link back to what's the purpose and what you're trying to achieve. Okay. So, first thing we're going to examine is different stages of motion on our projectile throughout the journey of its path. Hold on, Mohammed.
Okay, the students are demonstrating their learning. Either by making a meme or by posting in the demonstration learning share document. So here the students are trying to demonstrate their learning using a meme, but it might be self-apparent that they're not very capable of taking the task seriously, and they just come up with comedic memes only. Video doesn't seem to be loading. This one says that they're trying to demonstrate projectile motion and is only able to illustrate that sad face because his parabolic path of projectile motion is not straight, but it's not necessarily addressing the key selection criteria. And again, some more comedic memes that aren't addressing the demonstration of learning, where they can just get North Korean dictators to as an example of their learning, which is not appropriate.
So, a little private reflection on my physics lesson. Well, what I tried to do was to set up a reflection task where the students were to demonstrate their learning, and this was to be done through them sharing evidence in an online shared document, collaborative document, where they may take a photo of their work and upload it to the document, and then put a written description as to what this piece of work is demonstrating, what they have learned. So here is, at the end of the session, the two examples of students being able to complete that task in the time. So they've got a snapshot of their work as presented here, and a little description about what they've learned. But I'm finding that their written description on their reflection is more generalized overall, and it's not specifically relating to what the piece of work here is demonstrating from my point of view. Same with this one from the second student, and in particular whether it was he really understood what he was describing is again in question, because he chose an example that I had myself did many annotations to his work to guide him through answering the question. So it wasn't purely his own work. He drew on much of my input and my feedback to him to be able to answer the question. And he says that from that he was demonstrating the learning correctly. And again, his description is rather generalized description of what he's learned rather than specific to this example. So the students, I find, either hesitant to be able to demonstrate their work in this kind of fashion, or they attempt to do so but not fully understanding what they've learned or what they're demonstrating when they produce a piece of work. So alternatively, what I had given them an option to be able to do was also, as outlined in the Google site here under the task, so I'll pick one out, was them producing their work in a meme form, which I thought would be an engaging way, but perhaps slightly too engaging because they're not taking it seriously in trying to show that they've met the success criteria. The example that I gave to model was along the lines of this one. So this one here is the one that I posted, where I said, okay, get a piece of work or a piece of working out, and then create a meme with this kind of wording. I have success when I can find the final velocity of a falling object using energy. So using the wording of the success criteria itself, and create a meme around it. But many of the students have struggled to do so, or to do so in a serious manner, and they're more inclined to just have fun with it and be comedic, maybe because their understanding of memes is that they are of that nature, of fun and entertaining, and have nothing relevant to serious reflection on their learning. So I would regard this strategy to help them reflect on their learning as not so successful. So what I'm going to do from here is persist with the boring shared document on demonstrating how they've met the success criteria and how they've met the learning intention. But I'm going to have stricter expectations such that it will become an exit pass for their lessons, such that if they don't produce an accurate image of their learning and post it up on the board, on the document, and put an accurate description, then they must stay in the class until they've done so. Which seems rather punitive, but I think at this stage it's worth attempting to try and hold them to an account. So the next time I revisit this, I'm going to action that strategy, and I'll film it and include it in this in this video presentation with my personal reflection after the lesson. Cool. Okay, we're back. So, just a strategy that I thought can help with making this reflection task more accessible for the students would be on scaffolding some techniques on using ICT to be able to effectively and quickly engage in the task. It was assumed that students were capable or more capable than myself in effectively using the ICT to be able to work on the reflection task. That doesn't need to be the case, and I think it still needs to be shown and explicitly instructed to them and scaffolded to them. So the one thing that I've found is a very effective way to be able to share their work and post their work as an image through the Google Doc. So if they're working away, blah blah blah, they've got a piece of work and they go, oh, I've learned something. So then what they do, they can go insert image, then come down and go by camera, and on their Chromebooks they'll have their integrated camera right at that spot, and they click on that, and they should be able to select their camera. Hide. Here it is. This is the camera. When they click on the insert image by camera on the Google Doc, this pops up, and then they can show their work and demonstrate what they've learnt like this. There we go. Take a photo, click. Voila. And then we go insert, and there it is. It pops it, their work, and then we can describe what they've learnt. So they would add their name and explanation. What have they learnt? This piece of work demonstrates that. G'day. I'm making a video for the PPT process. Sorry. Yeah, that's alright. This piece of work demonstrates that I can add as well. Oh, I can't spell, that's for sure.
Oh, she needs a shelter, shelter for the night.